Now we enter into analysis. First, let me explain the entire thing. Later on, the data sheet I'll share it with you so that one example we can do simultaneously. Is it okay? Request you to please come out of your laptop. Now, when we are talking about the term regression, is it okay? What all do we have in a regression? What is regression? Who will take it forward? Pardon? Sensitivity of one variable to another. Okay. Okay. Fair enough. Point well taken. Okay. Perfect. Quite well. More or less all of you are in the same direction. Fine. I think that is how we summarize it. Mr. Kian and Ma'am Gitik, are we ready? Ms. Arva? Now, when we are talking about the term regression, there is one term as a correlation. In correlation, what will happen in any two variables which are given to you, if they are moving in a similar direction, is it okay? We say that they are correlated with each other. Now, when we are talking about the term correlation, it doesn't signify essentially that if they are moving in a similar direction, is it okay that they are having a connect with each other? It is not essential. Is it okay the price of two commodities are just increasing? Two commodities are there, price is increasing. Is it okay if I just try and put it on a graph paper? They will show that they are moving in a similar direction, but it is not happening that the price of commodity A is having an impact on the price of commodity B. So correlation between the two variables, it is not essential that they are related with each other. But whenever we are trying to test about the relationship, is it okay that how one variable has an impact on the another one? If the two variables which are moving in a similar direction, one is the cause and another is the effect. If that sort of scenario is there, then it is known as a regression. So regression is nothing, it is simply a relationship. Are we right? So the first thing which we understand, that correlation is there, which is simply a pattern of the data of moving simultaneously, but regression is talking about that the simultaneous movement, is it okay, it is happening because of one another. So that is talking about relationship. It is a thing. Mr. Tarun, in regression I have taught you about simple, multiple, linear, non-linear. Any idea about simple, multiple, linear, non-linear? Okay. When is to 1 is to 1, is it okay if only one variable I have taken? For example, that brand name has an impact on the buying of the product. Is it okay? It is only one variable we have taken together, then it is known as a simple relation. But normally in a business, simple relation doesn't work. It is more of a multiple relations are there. In multiple relation, Ms. Janki, what will happen? There are many dependent variables are there. There is one dependent variable. So when many independent variable and one dependent variable, when they are connected with each other, then it is known as a multiple regression. Are we okay? So in our curriculum, we are required to focus only on the multiple regression because simple regression doesn't work in day-to-day life, and especially in the business scenario, simple regression doesn't find a place. Now, when I'm talking about the relationship, so any data which is given to me, I'm required to connect them together. Mr. Rohan, when I connect them together, the first thing which will come in my mind, is it okay, any data, anything you put it in the software, some amount of connect will be there. Is it okay? But if it is simply a some amount of connect, it cannot help me to take a business decision. Are we okay with it or not? So what will happen? Whenever the data are given, first I'll put it in the software. Is it okay? The first thing which I'm required to monitor is the extent to which they are connected. And if they are connected to an extent of 70%, 80%, 90%, relation is good enough for me to study, and if the relation is a weak one, it is better for me to come out of the variables. Are we okay? So that is what we are required to study right now. So let us take some few examples. I have pulled in the same folder which we had done earlier, but at that point of time it was more objective. Now I'll give you the detailed explanation about each and everything. Pardon? Anything. So can hope if we, because the class has become a little very dull. Means, can I switch on the light? So otherwise it's really a dull environment. For some time and then we'll come back on that. Because of the light. Let it take it forward. We'll switch it on fast now. I have to complete 2 topics in this session, and both are quite extensive. Okay. So first give me 20 minutes, 30 minutes. I'll explain each and everything to you, and then nicely we'll work together. No, so this I have pulled from your statistics folder. I've just pulled right now. I'll upload it in a short time. Ms. Janki P, can I invite you today now? It's not uploaded, sir. So that now you can concentrate only with me. Yeah. Are we okay? Let us start together then. Means I'll explain, but you cannot start together with me. Close your laptop, half close. No. Let me explain one example fully. Is it okay? Ms. Janki, are you ready? So in this one, if we see the data, what is there? The last column is talking about the amount spent, and the other columns are about age, gender, so on and so forth. Ms. Janki, can you please zoom in a bit? Yeah, it looks... It's good now. So amount spent will depend upon the number of catalog we have issued. Is it okay? The amount spent will also depend upon the salary of a person. Amount depend upon so many other issues are there. I need to understand that how all other independent variables are having impact on my amount expended, right? Ma'am, just put your cursor in any one of the cells in Control A. Control A, yeah, entire data got selected. We can go to the first software, that is StatPro, down below the StatPro. Now which regression we should look for? Multiple regression. Let us go for multiple. Okay. Okay, now the system is asking what is the dependent and what is independent data. So my dependent data will be amount spent, okay. And now you may select all the data simultaneously. Okay. And just put a tick mark on the, yeah, fitted value. It's okay. 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 Fair enough. Kindly scroll on this side. Now you remember the first thing what I told you, any data you put it in the software, some relation will be there. But ma'am Gitika, the first thing I need to understand whether the relation is strong enough for me to study or not. So the strength of the relation is governed by a term that is R square, and this R square is known as coefficient of determination. This coefficient of determination should be 0.7 and greater. So we can write down the first point now, which is required. The first thing, regression, everybody know. You can write down the first point as regression. Point number 1 is regression. The second point, which is important, we know simple, multiple, linear, non-linear. No ma'am, just first point, just we are writing that regression. Now we know what is correlation and regression, that we are aware about all the points. The second point we are aware about simple, linear, multiple, non-linear, all that stuff we are aware about. The third one is dependent, independent data. What is dependent, what is independent? What is dependent and what is independent? Navigating to the next one. Then we have the next term, R square. Okay, next point will become R square, which is coefficient of determination. Coefficient of determination, which is equal. Now, this coefficient of determination explains that how much independent variable have a power to explain the changes which are happening in dependent variable. I am repeating again, very, very important. Ms. Bindu, what I am talking about, we have taken so many independent data. How much power do they have to explain the change which is happening in the dependent data? Is it okay? That is what is the number 7.716 means 71% changes which are happening in the dependent data can be explained by these independent data, right? Since the value is greater than 0.7, the model is good enough for us to take it forward. Are we okay till now? This R square value can be calculated also. We can also calculate this value. How do we calculate it? Ms. Janki, first make a total of two numbers which are given, explained and unexplained, right? Kindly make a total of these two numbers. No dear, this side. These two numbers under SS which are there, kindly total them. You can just select the two and select one more down. Yeah, now go to home, put a summation, click on summation. On the corner side, this side, sum auto. Perfect, right? Now that is the total, right? Now very, very important. Shwetaja, what is there? The overall change which is happening, is it okay? Part of the change, what do you mean by the term variation? There is one term variation. Your original data and calculated data should match with each other. Now what do you mean by the term original and calculated? You have the amount expended, that is already given to you. Another one, what I do, Mr. Kian, I have a regression equation. Using the regression equation, I can again calculate how much money you will expend. Are you getting what I'm repeating again? Or I give a pause on this particular calculation. Let me write a model first, and then after model I come back to this point. I think that will be easy for you to understand, right? So first of all, everybody got the meaning of R square? Right. No, sir, all. Right now, all. Later on, we will see that which is good and bad, and we can remove them as well. So right now, we are taking that all the variables which are given to us, if I try and use it to explain the dependent variable, then they can explain 71% precisely, right? After R square, there is a term adjusted R square. Write down the next point, adjusted R square. R square is known as coefficient of determination. Adjusted R square is comparatively a stronger measure than R square. Adjusted R square is a stringent measure in comparison to R square. Why it is stringent? Because when we are looking into the R square value, is it okay? It is not giving a weight to number of respondents. Okay. When we are looking into, or I can say that when we look into the adjusted R square, it also take into consideration the size of the sample. When we look into the adjusted R square, it is also looking into the size of the sample. See, a very simple, Mr. Mazid, if you are having 10 variable, you can do a regression with 50 data point, 100 data point, 200 data point. Is it okay? So there must be some difference. So there is one logical discussion that if your respondent size is 10 times the variable, then your data is good enough. For example, in this one, let's say, okay, I'll repeat. There were somewhere around 8 or 9 variables are there, age, gender, this and that. So 10 times of that, if there are 10 variable into 10, it becomes 100. Minimum 100 respondents should be there to get a good answer. Even if the data size reduces, then what you will find, the gap between R square and adjusted R square increases. Shall we try? Shall we try? So there is a small gap is there, little gap is there. Is it okay? But if I reduce the data, you will find that the numbers will become weird. Let us try. Ms. Janki, kindly go back to your data, please. Put a cut at after 11 or 10, means the 10th or 11th respondent, insert a blank line. Insert, yeah. Now what you do, you put your cursor on any one of the data, Control A, Control A, Control A, yeah. When you put a line and Control A, then what will happen? Below the line and above line, automatically it will become segregated. Now run regression once again with the same data. Means then model is weak. But in examination, if I give you a data and if R square is less than 0.7, you cannot just write one line, model is not good enough, so we won't do anything. No. Whatever I am asking, you have to answer all the questions. Otherwise, it will be criminal. And then I cannot. And in that case, what will happen? In that case, what will happen if you just write this line and don't answer any question? Even then, I cannot do with it. Is it okay? I have to give you marks. No. Girl, wait. Sorry. Let me try. Let me try. But these are all the datas, right? What is asking? No, take it on the right. Ms. Janaki, otherwise what you do, remove this one, cancel, do it again, Control A. No, simply it will work. Yeah, now go. Yeah, just say on the same data, yeah, Control select all. select all. Now what you do is, don't select in this one, just leave this one. Okay. Say okay. Say okay. Say okay. Oh. Please, let me take it forward. Thank you. Maybe the sample has become too small, that can also be a reason. I want to show adjusted R square, how it will change. Okay, now let us see now. You can see the gap between the two numbers have increased a lot. Is it okay? So when the sample size is small enough, the gap between R square and adjusted R square will widen. Are you okay with it? So this is a common thing when you are doing, for example, so Satish, you have done in your research paper, is it okay? In your ABR, the first thing they'll ask you to show the value of R square and adjusted R square, and when they find that the gap is too large, simply they'll say that collect more data. They won't even see what you have done it. That is what.
So even if the R square and adjusted R square are above 0.7, still you provide collect.
The gap between the two numbers should not be too large. There is no exact magnitude order, but normally the number will be 0.71, 0.70. Yeah. No, no, no. Right. Okay, guys, are we ready now? Sanjeev, actually there are lot many things are there, because as such regression itself is a textbook. So we can go as much deeper we can do it. The another subject extended version of this one goes into econometrics, a full course in itself. Okay guys, fast now. We need to be little fast please. Okay, so we are having a good understanding about these two numbers. Shall I close it? Next one. ANOVA now I have already explained to you, so I'll explain you about the ANOVA as well. But before entering into the ANOVA, let us understand the other consequences. Okay. R square we know, adjusted R square we know. The next thing is how to write a research regression model. Next thing is to write a regression model. To write a regression model, Mr. Rohan, we need constant and a regression coefficient. So these are the numbers which will help you to write a regression equation. Your equation will become expenditure of a person is 2.8027 minus 19.29 into age minus 46.74 into gender, so on and so forth. This is known as regression model. This is known as a regression model. Are we okay? Next one. In regression, you have a constant and a coefficient of all the variables. So the constant was 22.80. This is a constant, and then there are regression coefficients are there which help you to write a model. This is known as a regression model. So now we know what is constant, what is coefficient, and what is regression model. Are we okay? The next thing is, what is the meaning of regression coefficient? Now, what is the meaning of these numbers? The meaning of this number, for example, if I take catalog, the last one, if I take catalog, the data of the catalog is in numbers. How many catalogs I have issued? Is it okay? So, Ms. Getika, if I am telling 42.85, if you issue one catalog more, there is a tendency that you will find that the expenditure increases somewhere around $42. So what will happen, more and more catalog you issue to a person, then what will happen, that catalog will always keep the image of that particular store in your mind, and which will help in the expenditure pattern. Are we okay? Sure everybody is able to understand? No? Shall I repeat again? Okay. This particular coefficient I have taken of the catalog, last one 42.81. So what happened? This equation is 42.85 into catalog. Now if I put one catalog, then this will be number. If 2, then what will happen? Into 2. If I put 3, then what will happen? This into 3. In this way, what will happen, with every one additional catalog, the expenditure of a person increases by $42 approximately. Sure, everybody we are able to understand? Right. So more and more catalog you issue, is it okay? There is a tendency of more and more expenditure. Are we okay? Next one, sometimes you will find a number is positive and sometimes the number is negative. Within the coefficient, number is positive and a negative. Is it okay, Ms. Cookie? You can see that for a married one, closeness, the numbers are negative, right? What does it signify? That by increasing the proximity, the expenditure is reducing. And by increasing the proximity, expenditure is increasing. Somewhat like this relation is opposite to each other. Are we able to understand on this one? Now in this one, sir, first of all you'll have to look into the data, what is male and what is female. Now for example, I'm assuming that positive 1 is for male and 0 is for female. Otherwise it is already given in your data sheet. It is given in your data sheet. If I scroll up, sorry, gender, 1 is male and 0 is female. Now how do we interpret this number? What is the interpretation of this one? For example, this is there. If I put a 0, then what will happen? This number is not applicable. But if I put a number 1, then what will happen? Minus 19. Easily, just take it easily I'll explain it to you. If I put 0, is it okay, Ms. Bindu? Then 0 into anything is 0. So this number is gone. But if I put male, then what will happen? A number will come here 1. So 1 into this one, the number will be minus negative. What does it signify? That male have an expenditure of $19 less in comparison to a female. Is it okay? Male has an expenditure of $19 lesser in comparison to female. Sir, please. No. These are in numbers. If you compare, No, ma'am. No, ma'am. These are coefficient. Yeah. This will be in context to your dependent variable, which is the dollar. Yeah. Exactly. Right? Mr. Anand? Sorry, I couldn't understand. So whenever you are studying this one, you assume other things are constant. All cannot vary simultaneously. Assuming that means for one particular person, means all other one, if income is not changing, if age is not changing, and this is not changing, now you change your catalog. So with every change in the catalog, this will be the impact. But ultimately what will happen, all the simultaneously different. Right now, whenever you study coefficient, you assume other things are kept constant. Are we getting now? So we need only one thing. Stanand, are you able to understand? I understand your question properly. You are telling that it is for the collective one, right? But now when you are studying the meaning of the coefficient, you assume that all other things are constant. Fine? So we need your question.
You are considering that considering only male, then there won't be any female in the arms side.
No, so gender if you are keeping, is it okay? All other things I am not touching upon. So with every one change, yeah.
Because when your spending is equal to minus 46.74 into male is 0, so there is no change in the arms side. The moment you consider the female part, then the amount spent will reduce by 46.74.
Yeah, it is simply, if all other things are constant, how is the male and female expenditure changing? So if it is a male, on an average, is it okay, male expend this much amount less in comparison to female? Are you getting? Then it will happen that male expend more in comparison to that one. Okay, again it is a very important one. Now Janki, in the kids, if you see what is there, what is given, that the number is 208. Now this number, again a very, very important one. If I tell you to identify which variable is more having a more impact or more important, how you will justify, how you will say? Often it is a confusion, but that is not an answer. It is not that kids are more important in comparison to salary, no. Is it okay? It is simple. Looking wise, it looks very simple. It means it looks obvious, but it is not the case. Right? I'll explain it to you. First, I explain you the term kids. Is it okay? So what it is talking that if all things are kept constant, with every increase in the family size of one person, expenditure dips by 208. Now you must be thinking that it should be a reverse one, right? That with, I need your attention. Perfectly well, with increase in the family, the expenditure will increase, but actually the data has been collected from an electronic store. These data are electronic, it is not a general store. So as the family size increases, the expenditure on electronic item will decrease in comparison to essential one. So now, Ms. Janki, are you able to understand number 208? Okay, now your question. Her question is very, very important. She is saying that 208 is a bigger number in comparison to salary. So you should say that kids play an important role in expenditure rather than salary. All of you agree? But it is not the case. The unit of the data will also matter a lot. Right now, ma'am, what it is salary? It is with every $1 increase in the salary, the expenditure changes by this one. Now, if I write the salary, for example, the salary of a person is $60,000. I can write down this one as 60 and the amount I can write down in thousands. same number, either I write 60,000 or I write 60, or I write a number 6 and then I write down 100. Are you understanding? All the numbers are same, so unit will play an important role. So since the salary is given in dollar, with every $1 increase in the salary, is it okay the expenditure increases by $0.213? You able to understand now? I repeat. Here my salary is in dollar. So with every $1 increase in the salary, my expenditure increases by $0.2. Are we okay?
I understood the logic better, but I didn't understand how it is an more important variable.
Okay, we just come to that point only, the next point. Sure, everybody has understood how to write a model and how to interpret. Very, very important. I'm telling that how to interpret the regression coefficient is important. Are we able to write down this in your notes also? You have R square, you have adjusted R square, you know regression model, and you know how to interpret the regression model. Very, very important how to interpret a regression model. Okay, are we okay with it? Now comes a very important point. Now I'm taking your point into consideration. For every independent variable and dependent variable, what will be there? There will be a relationship, there will be a hypothesis. Mr. Shiv Kumar, everywhere for a dependent and independent, we were having H1, H2, H3, H4, H9. So what are these? These are independent hypotheses for every variable. So I have a hypothesis between a catalog and expenditure about kids and expenditure, salary and expenditure. Are we okay? Now what is your null and what is your alternative hypothesis in regression? Very, very important. Every time your null and alternative hypothesis in regression remains identical. And what is the null? Null hypothesis say that the relation doesn't exist. And alternative will say relation exists. I'm repeating again. Ms. Arva, in the null hypothesis I'm saying that relation doesn't exist. And alternative I'm saying regression exists. For each and every variable, the hypothesis remains the same. Are we okay? So, how many independent variable I have? Age, gender, custom, 1, 2, 3, 4, 5, 6, 7, 8. So, as of now, I have 8 hypotheses. Now, each and every 8 hypotheses, I need to prove whether null is true or alternative is true. Ms. Cookie, till now it is simple to understand, right? Now, in order to prove null or alternative is true, I have to explain you 2 methods. One method is either on the basis of critical value or on the basis of p-value, all of you together. But before critical and this one, what is step number 4th? Ms. Anshita, what is step number 4th in regression hypothesis testing? My first used to be null and alternative. Second one used to be which test I need to do. Third one used to be the level of significance. Fourth one used to be I have to calculate the t, the calculated value. Are we okay? Mr. Mohit, you can see the t value is there. There is a t value. Can I increase the font size? I'll just increase. It's okay, sir. It will just take 1 minute. So we know this number, we know. Sure, everybody, point number 4th. In point number 5, what I used to say, either by the critical value or p-value. But critical value is not given right now. But I told you each and every software now gives you a p-value. When p is low, null has to go. Are we okay? Now where p is low? Last 4 p are low. So null hypothesis has to go. What was your null hypothesis? Relation doesn't exist or relation is weak. An alternative is saying that relation exists or it is a strong. Yes or no? Sure, everybody? So can I highlight in this particular way that all these numbers are much greater than 0.05? So Mr. Mazid, can I just remove that all these variables are redundant variable? I don't want them. I have only these are the variables which are the good one, yes or no? Surely agree? So null hypothesis say relation doesn't exist or is a weak. Alternative say relation is good. Yeah. So I just need the green one, upper one I don't want it. Right. Alternative is true. Or are we okay? Again, I take you one line back. Mr. Sanjeev, whenever a researcher is writing, when a research will come into picture, he assumed that the relation is existing. Is it okay? That is what he want to prove, relation is existing or not. So when your P is low, relation is existing. Are we okay with it? I think Ms. Arva, some confusion going on. 100%? Okay, right. Yes, ma'am, that is what I told and now I come to your point. Is it okay? It is not the coefficient which matters because coefficient depend upon the unit of the data. A one kid and $1 is not the same thing, right? You cannot, very, very important, I need your attention. In this one, these all data are known as unstandardized coefficient. If you use another software, Ms. Gitika, it will give you one more column which is known as a standardized coefficient. I repeat my lines. These coefficients are unstandardized. So whenever the coefficients are unstandardized, they cannot be compared. If I try and convert into standardized coefficient, then they are comparable. Are you okay with the line? So if you want to compare the coefficient, I cannot take a call on the basis of coefficient because data are different. I cannot compare a kid with a dollar salary. Am I right? Right. Means the coefficient table, just relax yourself. I'll make this topic thorough now. And I assure you that you won't forget over the life. Ms. Cookie, are you okay? No. I'll explain it to you. Actually, she was not there in this particular topic when I was explaining, so a little bit here and there, but I'll put the things in place, right? So, okay. No. I never need it. I can teach at a stretch of 6 hours also. So. No. Because fine, I might have a capacity, but other side the citizen has a capacity. But yeah, teaching is, I don't feel much tiredness in teaching. Are we ready? Okay. So, what is standardized and what is unstandardized? One is salary, another is kids, another is catalog, another one is age. All are in different unit, you cannot compare. So whenever you are required to compare them, first of all, data need to be standardized. Now what do you mean by the term standardization? Is it okay? Your entire class work experience I have. Is it okay? Mr. Mohit, I am assuming that you stand in the middle. Half of your participants are having work experience below you, half of them are having above you. Now, for example, I assume that you have work experience of 8, girl, you have 9, and on this side you have 7. So, when we standardize, then what will happen? Your experience I consider 0. So she will have an experience of 1 year and she's having work experience of -1 year. Is it okay? Now I again take the same one. Is it okay? I assume average age one. Again I am assuming, sir, you are having 25, 26 and 24. So you become 0, she becomes 1 and you become -1. In this way, when all the datas are converted in such a way that the mean becomes 0 and the variation between them is standardized to 1 standard deviation, then the datas are standardized. And then you can compare the coefficient. Otherwise, coefficient cannot be compared. Because comparison happen among comparable. That is the first line which is taught in marketing. That whenever you are required to compare, the comparison can only happen among comparables. Are we okay? Sure, all of you? So that is why I am telling that in order to compare, regression coefficient doesn't take a... Yeah, right, right. Ma'am, these numbers are very important, but the numbers are not important for comparison. Is it okay? These numbers are perfect, very important, but this number and this number is not comparable. That is what I am talking. Exactly. Right. We don't have to do it. See, if you are required to interpret the coefficient, that is, you can do it. But these regression coefficient cannot help you in comparing. In comparing, you have to take a call of the p-values. Are we okay now? Sure, everybody? Ms. Anshita, please. Yeah, so I'll let you know how to write each and every equation. See, when you are having, I'll explain you how to write a data analysis. When you are required to write a data analysis, is it okay? These all calculation will go as an annexure. It doesn't fall in the report. Only limited things will go. Now, as I was talking about Internet of Things, that was my hypothesis. Now, see how hypothesis is written. Internet of Things impact means there is a relation. There is a relation. It is an alternative hypothesis because whatever researcher want to prove becomes alternative. Yes or no? So null hypothesis is what? Are all perception is no, Internet of Things doesn't has an impact on. Till now, when we were not aware about it, we have not done a research. Is it okay if somebody asks me, Mr. Mazid, that does Internet of Things will have an impact on adoption? You will just say no. But Ms. Bindu is a researcher and she is telling, yes, Internet of Things will have an impact on adoption. Now she is a researcher. So the burden of proof will lie on her. So she is saying that yes, there is a relation. So now you are able to understand everybody. Null hypothesis say that the relation doesn't exist. Alternatives say relation exists. Yes? Now when I look into the p-value, is it okay? I find p is low. Therefore alternative is true. So whatever she is saying is true. So the variable is important. Are we okay? Ms. Anshita, now you are talking how to write this one. So how I'll write in my data analysis. Little bit description I'll do, and then I'll write t value is equal to, somebody help me for catalog. I'm 16 point beta value equal to, regression coefficient is 4. Are we okay? Now for every one independent variable which you are having a relations with it. For every one, the same pattern will go back in your data analysis. Whatever pattern you have followed in your literature review, the same pattern will go in your data analysis. You will have one para for all the variable. Then you will have to mention your t value, your beta value, and your p value. P value, you have to simply say it is less than 0.05, greater than 0.05. If less than 0.05, then you will write down hypothesis is strongly supported. And if it is very close, you will say weakly support, means weakly supported. And if it is greater than 0.05, it is not supported. Done. So in this way, if you are having 6 hypotheses are there, prove, not prove, done. Your research is completed. Fine. Shall we come back? So it will rare circumstance, because always they are at 4 digits. Yeah, till 5 it is accepted. Okay. So this 5% means this is a 5% level of significance. Yeah. By default, even the softwares all generate the value at 5 till you don't put a command on it. Yes, so that is I'm telling that by default, if nothing is mentioned, if you remember in every hypothesis point number 3, what I wrote? It is 5%, not given by default, take 5%. In the research also, then what happens, you all have a general business research. If the research is a surgical thing, something related with medicine, gold, something more precaution is required, the percentage I'll change. Are we okay? Sarana? Research equation, regression equation, always written with unstandardized data, not with the standardized. No, so actually, as you do advanced analysis, then standardization is important. Then, sir, then you can compare. Because they are already, yeah, right, that way. Okay. It will go. This table will always go. But what will happen? Either you put it in the document or you put it as an annexure. I'll show you in a Danco. Is it okay? There are 7 tables are generated. So how do we put the 7 tables? And full article I'll show you so that you'll understand. Yeah. That is point number 3.3. Yeah. No, sir, it's nothing. I'll simply write that hypothesis strongly supported. Hypothesis is always alternative. It is never null. Research hypothesis will come only when there is a researcher. And whatever researcher is saying is always alternative. Make sense? Which one, sir? 0.17 is? Yeah, because it is 17, much greater than 5. 0.05. Makes sense? Right. Right. Yeah. Very important. Okay. Everybody listen to her, what she is telling. I think Mr. Kian will have to repeat the question and answer I'll take care of. Yeah, now what to do? So then what will happen? Is it okay? It is a way of writing now. So you will write down that t value is equal to this, beta is equal to this, p value at 0.10 means it is supported for 0.10 but not for 0.05. 1% means 10%. So see, you are saying 0.06. At 5% I am comparing with 0.05. At 10% I am comparing with 0.1. So when I compare at 5%, this is rejected. But at 1% it is accepted. For a 10% it is accepted. So 10% is a weaker one in comparison to 5. So I am saying that, is it okay that at 5% relation is not so strong. But if your rejection area would have been 10%, then it is accepted. Yeah, so, but I'm mentioning this one, I'm saying that this relation is weaker at 5% level of significance but get accepted at 10%. Yeah, that is what you are required to write here. Fair enough? Shall I come back? Okay. Okay, lot of points we have discussed on this one. So shortly I summarize, then I take the other points. Is it okay? Can we all come out of the laptop so that we can summarize? R square we know, adjusted R square we know, mod coefficient we know, how to write an equation we know what is t value, we know what is p value, we know what is null hypothesis, we know what is alternative hypothesis, what is alternative is the research hypothesis, and we know how to prove and how to disprove, and we also know how to write in a data analysis report. Makes sense? Okay. Next one. So more or less this is done for us. Now I'll explain it to you that how R square can also be calculated. And then we enter into some other issues which happens in regression before we take a call. Either you take a call on the p value or t value. As your t becomes bigger and bigger, your p will become smaller and smaller, you can check. Now the next question was like this only. In this one, if you are required to compare which is more stronger, then I cannot take a call on the p, then I look into the t value. So next line. As your t value become bigger and bigger, is it okay? The relation is becoming stronger and stronger and stronger. That is why, Mr. Vineet, in the report, you are also required to mention this number. We do mention this one, but it doesn't have so much statistical significance as this much. That it is your one. You can keep a pattern of literature only. So what happened when I'm reading it, everything falls same way, the synchronize your work. Are you okay? Fine? Can be positive, negative. Because when the t value is increasing, your answers are going in the rejection area. Rejection can be positive or negative, doesn't make a difference. Whenever your answer enter into the rejection area, alternative is true. Are we okay? So more and more t, is it okay? More and more deeper you are going in the rejection area, alternative is becoming stronger and stronger and stronger. Are we okay? Next one. One thing I'll teach you about the residuals. Is it okay? What do you mean by the term residual? And then explain the value of R square and then another consequences. Is it okay, Mr. Tarun? Okay till now? Right? We take it forward. Ms. Cookie, all well till now? Great. Next. This topic has somewhere around 15% weight in your entire, even in from the examination perspective also approximately 15% weight this entire regression has. And even in, if you have complete understanding about the regression, your data analysis is also more or less completely understandable. Okay, a Danko is the same higher version of that one, in which all these terms will come again, but few more terms will be there. So, what I was explaining you, residual, right? I'll just take a tiny one, y is equal to anything 20. Okay, for example, this is a model, just randomly I have taken, otherwise I'll have to turn again and again. Now, in this model, Ms. Janki, if I put a value of x1 and x2, then what? First of all, I already have a value for this one. All of you is okay? First of all, I already have a value of this one. Now what will happen? I'm assuming that x1 is talking about your age, and this is talking about your work x, and this is talking about your, what should I put y as? Salary. Is it okay? I have your salary. Now if I put the age and your work x, then again I'll get a salary. Is it okay? So the numbers which I put and the original salary, there will always be a little mismatch between the two. Because in order to calculate this equation, I have taken all your data. Strana, it is coming to your point back. I have taken entire cohort data. Then I made an equation. So the equation is a culminated of all the people, right? Now if I want to see her, then I have taken her data and put it. First of all, I have salary of Ms. Janki. All of you agree with me? Using all your data in an equation. In equation, if I put Ms. Janki's data again, I should get her salary back. Yes or no? Are we okay with it? Mr. Rohan got it. But the answer which I'll get it, from the equation will be different than our original salary. Yes or no? So Satish, agree with me? I repeat my question again. I have her salary. I have salary of all of you. I have age all of you. I have work experience of all of you. So first of all, using your age and using your work x, I have prepared an equation. This is an equation. This equation is true for all of you. Now, when I put your data, I'll get your number. When I'll put her data, I'll get her data. Makes sense? Mr. Satish, I already have her salary figure. Now I put in the equation, when I put the data, again I'll get a salary. The two numbers should be identical, yes or no? Because after all, this equation I have prepared from your data only, so it should match. But there will be little mismatch. Why there is a mismatch? What can be the reason of mismatch? Maybe your R square is 0.8, means your model is not 100% accurate. In order to determine your salary, it is not only the age and work experience, your education also matters, your other characters also matter. Is it okay? So my model is 80% accurate only. Are we okay? So that is why your original data and calculated data doesn't match with each other. Are you able to get it? This mismatch between original and the calculated data, Mr. Bindu, that is known as variability. Are we able to? Variance, that is the variance between the two. Residual is what? Is a variation. Yes or no? Last 2-3 lines and I'll close it. I know that we have done a lot. Now, when I try and study this variation, it gets split up into two parts. This variation which is there, when I try and study what is the cause of it, it gets split up into two parts. One part I have an answer, I have an explanation why it is happening. The other part is there, I don't have an explanation. Are you able to get? Exactly, right? So one part which I'm not able to explain is some reason. And another part is I don't know, there might be some other data which is unexplainable. Are we okay?
So it might be
Sure.
some other variable that we have not taken.
Some other variable might be there which I have not taken. Is this part understandable? Sure. These are the two terms. Definitely, ma'am. Definitely. That is what is a research is about. So if you do a research and you find that your R square is very low, means your research is weak because there are some variable which you have missed out. That is the quality of your research. Now are these numbers understandable, these two numbers? Don't go into the number. Explain and unexplained part, I have done it. Yes? Yeah. Is it okay, so I'm telling that my model is 80% accurate. So that is why the deviation is there. So my original salary of Ms. Janki and the calculated salary of the Janki doesn't match. Is it okay? What is the reason? One reason is that there are certain variables which are not taken into consideration because my R square is 0.8. No, so that R square and P square is not connected with here. That P square is talking about at what level you prove it, whether null is true or alternative. That is another story. Are we okay? I need your attention. Last row. We are just closing it. I can understand. Sanjeev, I'll give pause now. Okay, please, I'll request you all. Okay. So what I was talking? Yeah. Is it okay? So the deviation between her salary and this one, is it okay? There is a deviation, is there? Now I'm trying to understand the cause. What is the cause behind it? So the cause get divided into two parts. I have an explanation why it is. I don't have an explanation. Are we okay? This total is the total variation in the system. Is it okay? Now this part is what I have an explanation why it is happening. See now, is equal to, this I have an explanation, the lower part I don't have. This divided by total. Was this your R square? Everybody got the meaning of R square now? Here I'll give a pause. I think now it will be too much to take it. Once you come, then I'll explain you Adanko. Adanko definitely not an exam. It is not a part of exam at all, but it is an integral part of your research. Fine. Before we take it forward, one summary more and then we give a break. Are we okay? Close your laptop for 2 minutes. Just leave everything. Relax yourself for 5 minutes. Close it. No need to write also. Ready? We take a call now. Mr. Teja, will you start? Just narrate, keep on narrating the point of regression. Yeah. In a sequence, what all we have learned in regression. Yeah, everybody clear with R square coefficient and regression? Second point. Simple multiple we are aware about. Linear, non-linear. Linear means straight line, non-linear means not a straight line. Next point. Perfect. We know dependent, independent. Only then we can run a software. Next. R square is explaining the power of it and we want minimum R square should be 0.7. Next. Regression model, we know the coefficient. Coefficient help us to write a regression model. Then the next one. Very good. How to interpret the regression coefficient, that also we understood, everybody? Sure, 100%. Are we okay? Then what is the meaning of this number 42? What is the meaning of this number 208? What is positive? What is negative? That also we know. Very good. Next point. Yes, ma'am. Then we are required to look into the t value, p value. Before that, we know null and alternative. Null and alternative help us to identify null is true or alternative is true. That also we know. After we have done this one, we are able to identify good and bad variables. Next thing what we studied, standardized and unstandardized coefficient. Is it okay? Next to Ms. Shitija, Ms. Janki P. Will you explain us standardized and non-standardized? Standard deviation, we make it as a 1 unit, and then the coefficient can be compared. Unstandardized data, regression coefficient cannot be compared. Okay. Next one, Mrs. Sanjeev, what was residual?
Value when you calculate using the regression equation, when you calculate the value, and the value you have in central data, there will be a difference.
Mismatch is there. The cause of mismatch is divided into two parts, explained and unexplained part. That also we have. I think these are the points. Mohit, please. Okay. Good and bad variables, so what we have done is we are simply looking into the p value. As your p become low, alternative is true. And alternative is the researcher's hypothesis. And researchers say that there is a relation. So when p is low, relation is there. Variable is good. Sure? Are we okay? One line and we close it. Mr. Vineet, how to write your data analysis? For every independent variable, we have written a literature. For every independent variable, we have written a literature. Now we write data analysis. One word wrong. My wrong. Data analysis we have written in 3.3. Then 4 will become findings and analysis. Analysis and findings, wherein all your hypotheses will come one by one. Okay. So, okay, I'm not feeling well. Not feeling well. Are you okay or not well? So just one means after a little explanation about that one, that in this one what played an important role, because what happened, we were having a sub variables also. So we'll have to write down a little bit more when I explain you Danko, then you will get the importance of sub variables. Is it okay? So 1 para will go for all the 6 variables, and then in this way you are required to write your t value, your beta value, and the value. Hypothesis supported, strongly supported, weakly supported, not supported. Are we okay? That is not a data analysis, that is data analysis and findings and data analysis, and that we are required to write. Yes. Yeah. Right. Expenditure will depend upon catalog, so it is proved. So then what will happen, if it is proved, then you get an answer that okay, we should issue more catalog to get more customers. Right. No relation. And if it is proved, means relation is there. So by issuing more catalog, business can increase. So as a businessman, now what you will take a decision, I need to issue more catalogs. Are we okay? Right. Ask. Completely understand. Is it okay? The statement will remain like that only. Is it okay? But in that case, what will happen? Researcher is telling that there is no relation. Is it okay? Fine. So I can have that way, but that will become untrue. Then what everybody was saying will become true. So in that, we have to change the hypothesis in the statement.
But it's happened, right? It's not that it's always the case that for every research and null it has to be opposite of null is what we're saying. It can be opposite as in true by default.
So you have to put your hypothesis in that particular way. Exactly. Ma'am Arwa, can I assume that now 15% is done? Fully you can get 100 on 100 on this? Once we come, then we'll have a quiz. Don't get scared. That quiz will be like a practice quiz. Is it okay? So that you get a confidence and then we move ahead. Mr. Rohn, right? Nice. Have a nice break. Come back soon. So what time we are meeting again? Okay, we meet at 2 o'clock.